So hey guys, my name is Ruben Lewis, and today I'll be explaining the first DLIC practical, that is the working of an inverting and non-inverting amplifier using an OP07. So let's get started. The software we'll be using here is LT-Spice. Let's click on new schematic. The component we'll be needing is an OP07. Let's place it here. Click escape, minimize it a bit. Now I'll be needing two resistors. Two resistors. To rotate them, you need to press Ctrl R, place one here, and place R2 parallel to the OP07. Now I need three voltage sources. I'll be placing one here, V2 here, V3 here, and I'll minimized a bit. Now I'll need three grounds too. Now this is a inverting amplifier because the voltage source is being connected to the negative end of the OP07. Let's connect all of this with the wires now. So click on it and connect it. Connecting V2 and V3 too. Connecting them to ground. Now let's go to LabelNet and name our VCCs. So these are VCCs and VEEs. Let's place them here. Escape. Now we'll need V in. So V in here. And the V out. So now I'll be giving the values to the components. So here I'll be giving an advanced value, a sine value. So say offset voltage will be 0 volts, amplitude will be 0.25, and frequency of 1K. Here R will be 1K. This, so RF will be 2.4K. So the formula for V out in an inverting amplifier is minus RF by R1 into V in, that's the input voltage. Here I'll be giving a value of, say, oh sorry, mistake. In my V2 here, 15 volts. 15 volts. So I think I'll be giving all the values. 1K, 2.4, 15. Yeah, okay. So I just need to give the stop time. That will be giving 4 ms and start to go. So I'll press the run option, and here I'll place one of my probe on V in and another one on V out. So here you can see for an input of 0.25 volts peak to peak, we are getting an output of minus 1.2 volts peak to peak for a gain of 2.4. So yeah, so now we will see the same process we used for the non-inverting amplifier. Since I've already done it, I'll be opening my file. So here I'll be using a non-inverting amplifier for a gain of 4.8. Let's open this up. This is a non-inverting amplifier. The reason behind this being a non-inverting amplifier is this, because the voltage source is being connected to the positive end of the op-amp, that is the OP07. So here I'll be using, so this is a gain 4.8. Basically the formula for gain is 1 plus RF by R1. So since we have a gain of 4.8, the RF value will be 3.8, and here we will be taking an input of 1 volt. So let's run this too. So I'll be placing the V in and V out. So as you can see, for an input voltage of 1 volt peak to peak, we are getting an output of around 4.8 volts peak to peak. Now if I go here and if I change the input voltage to say 10 volts peak to peak, to around 5. So here as we run this, you can see we have been getting a different graph. So here we can see that we are getting saturation. So you can see we are getting a saturation value of around 14.03 minus 14. So here you can say the saturation value is somewhere around minus 28 volts peak to peak for a gain of 4.8 and an input of 10 volts. So here I think we can conclude the experiment. And here I've spoken about the inverting amplifier, the non-inverting amplifier, and also the saturation, how the saturation takes place. Thank you.